Welcome to Robots with Mixed Reality. Nice to see a full room. I'm Patrick Misteli. Let me quickly introduce myself for those who haven't seen me before. I've finished my master's in 2017 here at ETH in computer science. So I know these walls quite well. So all of you who are studying here, I know what it's like. 1 month later, Microsoft got a hold of me and I started as a program manager in Paris. I spent the rest of 17 there and all of 18 also. And then middle of 2019, I switched roles within Microsoft and started as a premier field engineer here in Zurich. Then beginning of 2020, Marc Pollefeys, which some of you may know, he's 50% professor at ETH and 50% Microsoft employee. And he's lab director of the Mixed Reality and AI lab in Zurich. He got a hold of me and asked me if I wanted to be program manager, and of course I said yes. So I've been there ever since then, which has been a lot of fun. I'm happy to show you some stuff. Apparently I'm the record holder with most talks at VIScon. I've been at every VIScon so far. They keep inviting me back, so thanks for that. I thought I'd give you a brief history of what VIScon was for me for now. So here's an overview of my talks, and I gave them a coolness rating, so you know what you missed. VIScon 18, the very first VIScon, I started with what's it like to be a program manager at Microsoft. By the way, all these talks are available online on some VIScon web pages. What's it like as a program manager at Microsoft? What does ETH teach you and what doesn't? So they don't teach you that. Oh, there's a blackout button. Okay. Beautiful. So that was fairly cool, I guess, but we can do better. VIScon 2019. We looked at the HoloLens, which was just recently, was just then released, actually. And there were, I think, 3 or 4 devices in Europe, and we managed to get one at VIScon 2019. So we looked at the HoloLens. Quite fun. So we built on top of that VIScon 2020. We still have the HoloLens at Microsoft, but now we do a shared experience. So we have multiple HoloLenses, all in the same experience. And we played beer pong. I don't know if some of you remember that. We have 2 HoloLenses, a virtual beer pong table, and we just played beer pong. It was really fun. We still made the joke there, yeah, we can stay until they turn out the lights. We did stay until 11 p.m., and they did turn out the lights on us. So that was quite cool. So, VIScon 21, what can we possibly do to make this, to kind of top this? So, here's what I thought. What we showed last year was HoloLens shared mixed reality experiences. And here's what it enables us. We can have people looking at, I don't know, industry, machines, extra information. You can have remote guidance, inviting someone virtually to your space. It's being used in medicine, in research. I think this is a picture of Airbus. So generally sharing, discussing 3D models, sharing a space. Maybe you noticed something here. This is highly discriminating. I assumed that you're human, which means all of these, while humans were having a party in mixed reality, there's a whole bunch of sad robots out there that were not invited to this party. So why should we change this? Why should we even care? So this is what this talk's about. Let me first take a few steps back. What is mixed reality? Quick show of hands. Who knows what a HoloLens is? This is so cool. 2 years ago, like 5% of the people hold up their hand. Last year, 80%, and now almost everyone. Really cool. For those of you who don't know, which is, I think, like 2% who maybe didn't pay attention, augmented reality, everyone knows this. Pokemon Go, Peak Finder, all these kind of apps that work on your phone. They project the camera on your phone and add something augmented to it. We have virtual reality, which is your Oculus is a famous one. You're inside, you're submerged into mixed reality, you don't see the outside anymore. Also a beautiful system. And then we have mixed reality. So just to get our terminology straight. Mixed reality it's almost like virtual reality. The difference is when I wear the HoloLens, I see the real world outside. I don't see a projection of the camera, I actually see through the glasses. Plus I see holograms on top of it. This is not supposed to rate any of those. Depending on your scenario, each of those make perfect sense. More difficult question. What is a robot? want you to think about this for a second. It's not an easy question, I know, and actually talking to roboticists for the past couple of weeks, if you ask 10 roboticists, you get 11 different opinions on what a robot is. If you ask someone who has no engineering background, they will usually tell you, well, this is a robot. And if you thought this was a robot, I'm sorry to burst your bubble. This was an actor, and I think this was just a remote-controlled car, as far as I know. The closest we got to this is the Boston Dynamic Atlas. So this exists, this works. We also have the Boston Dynamic Spot, which is sitting down there, ready for his turn. We have the in-house animal, of course. We have autonomous cars, warehouse robots. Notice that all these robots, the ones that actually are robots, they all have some kind of environmental intelligence. They know where they are in the world, which we're going to focus on a bit more later. We have robot arms, which can be used for, well, whichever, packing, any conveyor belt working, assembly line, maybe paint jobs, anything. Those have been around for quite some time. This thing is called the Da Vinci. It's used in medicine, so we can do more precise movements. Even your lawnmower or your vacuum cleaner, I'm sure you know those. Depending on the definition, even your washing machine or your dishwasher could be considered a robot. One definition, which some people like, I'm one of those, is a robot is a machine that can carry out a series of actions automatically. Just that. Now, while roboticists may disagree or don't agree on a definition, they do agree on the 3 Ds of what robots are supposed to be used for. So this is 3 Ds, not Gs like the COVID. The 3 Ds are robots should be used for dull work. Now, dull work is pretty much anything that's repetitive, it's tedious. For example, moving a box from A to B, painting the same car door 100 times a day. Robots are perfect for that. Second D is dirty. Dirty work like sewage, like maybe mines, anything that's a human could do, but it's just, why should we if we don't have to? Robots are good for that too. And the last one is dangerous. Of course, it's no secret that the army is using a lot of robots as well. There's stuff in space exploration, bomb detection, detonation, all of those things. Robots are very good to do all those things. So how can robots benefit from mixed reality? Why should we even invite them over into our mixed reality party? There's 2 things, spatial intelligence and human interaction. Let me expand on those quickly. For spatial intelligence, it means we can do mission planning and navigation. And in simple terms, it just means robots know where they are, which sounds like a very simple, dumb thing, but it's very powerful. Let me give you 3 examples. Let's use our Roomba. And here's our apartment, and we have a Roomba here. Now, the very, very dumb Roombas will just go straight, they drive into a wall, they do a random rotation, and they do that, and I hope some point that your apartment is clean. If the Roomba actually has spatial intelligence, as it goes around, it can map the area where it's been already, which means it doesn't have to go back to where it was before because it knows it's clean. And you can go one step further. Once you just mapped your entire apartment, the next time it goes cleaning, it knows where it hasn't been yet. So it can even give you a time estimation of when it will be done. So Roomba knows where it has been and knows where it has to clean. Nice. Let's use another example in a warehouse. Let's say we're in a warehouse here. We have different aisles. We have a bunch of workers. And here's a maybe slightly bigger Roomba, a warehouse robot that we saw before. And here's me. Now I can put a packet on him and just ask him to, hey, can you go to aisle 4? And the robot, because it has a map and it knows where aisle 4 is, he'll gladly just go to aisle 4 without any remote control or anything, because the robot knows where it is. Let's quickly take a trip to Swiss mountains. We have a little mine and maybe a little robot that, plant explosives or can do digging or just general reconnaissance. Now, of course, this is a dangerous and dirty job for a human. So wouldn't it be nice if I would be in some other room, beautifully air-conditioned, in front of my 2D screen, and I have a map of the mine, which means I can define a path now for the robot and tell it where to plant the explosives, maybe, and send that to the robot. And he will gladly go into the mine and execute that mission, because he knows the map, he knows where to go because I've told him. These are just a bunch of examples. There's a lot more, of course, that you can think of. So this was spatial intelligence. But that's only half of the benefits we get. So robots know where they are. But remember, we are already at this mixed reality party. We're part of that already. So we can actually interact with robots better now. In short, robots now know where humans are. Again, sounds like a simple thing, but very powerful. Let's use security or maintenance patrolling, for example. We have a bunch of buildings, and maybe there's, as a maintenance, you have to go around to make sure the, fire extinguisher is not expired. I think I have a laser on here. Nice. And maybe there's a fire extinguisher here or a label, or as a security patrol, you have to check that this door is locked in a certain way. So what we saw before with the mine, I could use a pen, not a pen, like a software on my PC and just define the path. And then the robot can execute that. That works. But if we do think about it's not just walking here, it's checking this label here, it's making sure the door is closed, the fire extinguisher here is not expired. So those are specific tasks. And yes, maybe depending on the software, I can rotate it on the screen and kind of define it. But much easier, if I'm one of those patrolling people, I've done this 100 times. So what if I just, before I take my next patrol, I wear the HoloLens and I walk the whole path. And as I create the map, and as I walk through it, I can define the path inside. And I can also define as I go, I can maybe stop here and look at a specific part with the HoloLens, and depending on the software I've implemented, I can adjust and tell the robot, hey, by the way, you need to look at this one, and maybe here the door, make sure it's red or whatever light it's supposed to be. In short, I can do mission planning on site or in situ as I walk through it. Let's go back to our warehouse robots. We again have aisles, and here's me with a HoloLens. And here's a slightly more sophisticated Roomba now with an arm on top. Before, we just asked the robot Roomba to go to aisle 4, but the Roomba didn't know where I was. It didn't care. He just had to go to aisle 4. Now that he knows where I am, what I can do, which might sound incredibly simple, but it's very powerful, I can ask the robot to grab this. Now, I want you to appreciate something as a human. If I would ask you, any of you, to grab this object in front of me, you all would know what I was talking about. For a robot, this is incredibly difficult because he has to translate from your coordinate system what you mean to his coordinate system and kind of has to know, okay, I obviously have to go forward and then to the left to grab this. Very powerful, very simple for humans. Last one, we can visualize now what robots' intentions are because we share the same map. For any robot, any larger robot, they usually have a cage around them or a very big red button. Well, the red button they always have anyway. Wouldn't it be nice if I can wear a HoloLens, and even if I have a huge machine that's moving, I can see where the machine will be in 5 or 10 seconds, just as a hologram. I still see the machine, and I see where it goes, which means if I'm in the way, another person or an object's in the way, I can still do something. I can either remove the object or hit the red button and it'll shut down. Very powerful, very simple. So much to human interaction. Again, these are just examples. There's a lot more, some of them being used and being tested out in industry. So how can we share the same space? Now that we know it might make sense, how do we actually invite the robots now into our mixed reality? There's 2 ways which I quickly want to cover. One is marker-based. We'll go into division-based in a second. Marker-based, some of you might already know. It's also been used in mixed reality a lot. We have a marker. It can be a QR code. It can be a picture with a lot of features. All of those work. And we have our devices, HoloLens, robots, Android, iOS phone, doesn't really matter. Now they can look at this marker that they have in front of them, and what they can do, and we as humans can do that actually too, quite well. We can define the coordinate system of that marker. How do we do this? The red and the green one is pretty easy to define because you see it. The blue one, which is the z-axis, depending on where you're from, is also somewhat easy to define by the shape of what we see. So if this shape here is perfectly squared, even as a human, then I know I'm staring at it from directly above. As soon as I have it at a slight angle, it distorts slightly. So I can still calculate where I am. And of course, we can implement this so robots and phones can do the same thing. So what happens now is I not only know where this marker is, I actually know where I am in relation to this marker. Again, if I stare directly above it and I see it's square, and the size of it tells me how far away I am. So maybe if it's super big, I know I'm like 2 or 10 centimeters away from it. If I'm further away, it's going to be smaller. So I can synchronize this position with each other, which means I can tell my Android device, by the way, I am 5 meters to the left of this marker, and tell the robot I'm there too. So we can now communicate, we're all sharing the same space. Is this good or bad? Well, depends on how you see it. Pros are, you can do pretty precise positioning under ideal conditions. If the lighting is perfect, the markers are good, it's quite precise. It's widely supported, cheap and easy, it's been researched for years, which is also why there's incredible fast detection nowadays. I've seen a demo where they can detect, I think, hundreds per second of markers, quite precise. What are the cons? We need to adapt the environment to the robot. Depending on your scenario, that's okay. But wouldn't it be nice if we would adapt the robots to our environments? Because now we have to hang up markers everywhere. Again, in some scenarios that makes sense. It's also cheaper and easier maybe, but in other scenarios, you don't want to have that. All agents must observe the same tag. So if we have a tag, we must all look at it first. We cannot just go into a room and everything just works. Everyone has to stare at this specific tag. Moreover, the accuracy is viewpoint dependent. If I stare at it directly from above, perfect accuracy, most likely. As soon as I walk away, the further I go away, the smaller this thing gets. One is the detection, and the other one is, even a slight angle rotation is going to have a huge effect on my position. This is not supposed to be is this bad or good? These are the pros and cons of it. Depending on your scenarios, it makes sense or it doesn't. So let's have a look at vision-based. I want you to look at this image quickly. It's going to get slightly meta now at this point. I'll give you a hint. This is this room. Now I want you to, it's a question to you, you don't have to answer. Where was this camera when this picture was taken? Right, I see some of you pointing there. Now here's the thing, what you just did, and I assume most of you would have gotten that answer right, even those who didn't point. What you just did is amazing. And that's also amazing. Nice. What you just did is actually incredible, and it's something you should appreciate. I want you to take into account, most of you have probably never seen this exact image. Most of you did never, I'm going to spoil the answers over there, of course. Most of you have never stood in that position. The two people sitting there, yes, you have it easy. But most of you most likely have never actually seen this exact image, yet you're still able to know where it was from. We can take it a step further. This very room, right now as it is, it does not look like this. We have people sitting here. We have this COVID panel over here, and I'm standing here. So things look slightly different, yet still you are able to know where this is. I want you to think quickly how you managed to do that. The way you did it is, well, you recognize these are, you have the desk, the chairs, you have the front desk in front, you have the empty panel, we have the door. All of these little features that you as a human were just able to, that's over here. For a robot, it's very difficult. Now, wouldn't it be nice if robots could also have that kind of system that all of you learn, I don't know, at the age of probably 1 or something. It's just basic orientation skills. Turns out, robots can. Welcome to spatial anchors. What is a spatial anchors? I'm glad you asked. Let's create one. So, imagine we're in this room, and here is me with a phone, and I'm going to create an anchor. Now, one thing I want to get across, an anchor is not the content. An anchor is just a common reference frame for placing digital content. It's basically a fancy way of saying, this is a point in space with orientation. That's all. It's like me defining this corner over here, this is my anchor. So all of you now can agree, and if I would place an object 1 meter on top of this anchor, all of you would know it's over here. It's stable to the real world, which means, oh wow, it's really white, but there's supposed to be a window over here and there's a door over here, more or less. So these are the features that are bound to this anchor. And which means if I move around, those features are still going to be here, just like you recognized the desks and the chairs before. There will be at a slight different angle. Again, something you did in your brain before flawlessly. But knowing that the door is now maybe a bit more to the left because you moved, I still know where this anchor is. And of course, we can persist it over time and over different devices by using the cloud. Small privacy note on that. So I'm going to talk about Azure Spatial Anchors. So there's multiple cloud providers that actually do this. I know this one from Apple and Google as well. And I'm sure there's others. For Microsoft, I know for a fact that if we place, let's say, a dog hologram over here, I can anchor that to the object. I'll say, well, it's on the anchor itself. And then I upload the features. I don't upload any images. Because the service itself, it doesn't care about the images, weird enough. We as humans, we will care about images. You would want the image of the door and the window. The service itself, it doesn't care. It's just a feature point cloud. So this is what's being uploaded. And of course, another privacy note, if you use Azure Spatial Anchors, only you and whoever you give access to your account will have access to all of these anchors. Cool, one last time. And then we're going to boot Spot. Let's boot him now, because he actually does take some time. He's going to start breathing a bit loud, but there we go. So one last time, what's happening here is I have a tablet or any other device. I look at something specific. Here we have a table, and I collect the features. And then if I want to, I can place a hologram, and all of this is uploaded to the cloud. So the features and the holograms. Only half magic so far. Now the second step is I come back with another device, and I look at the same space, and I ask the service, hey, by the way, I see this thing here with the features. It looks like a wooden thing, and it looks like the corners over here and here. And then the service will tell me, wait, this fits in the map that I have, which this guy over here created. But it seems like the left corner over here, now for you, is your front corner. But I can match it, literally what you all did with the photos over there. I can match it, but I know you're just slightly tilted, you're over here. So that's all that happens. It's very simple and, of course, highly complex in computer vision. I'm going to let it play one last time. So like this, then we can have, have the same hologram at the same position. Right, do it again. We scan the features. We can place the hologram if we want to. We can also just save the anchor without the hologram. The feature points get uploaded. I come with a second device. I ask the service, hey, do you know where I am? And the service says yes. Cool. Now, like last year, I think I'm good with time. I always like to take this very high-level... Okay, that's a bad sign, actually, that he takes out the screen. I like to take this whole complex system of years of research, computer vision, robotics, and let's do something incredibly simple with it. So what we're going to do now, and I hope it will work, it seems like it changed its IP address, so I'm going to let him fix that. What we're going to do now is I will take out the HoloLens, I will create an anchor, which is what we saw before, and you will see me doing it live as well, I hope. And Spot, the robot, will find that anchor. So that's the boring part, because then Spot just has an anchor. You don't see anything yet. But that means Spot and I now have a common coordinate system. Same as me saying this edge now here is our common coordinate system. Which means I can tell Spot to go wherever I want to. And so what we're going to do is I will throw a virtual ball, and Spot will go fetch it, pick it up, and bring it to me. All right, so here's why it's quite difficult to get the whole stack going. We're going to explain also why this may be a problem.
ETH network.
Yes, so ETH network, it's important that we communicate with the Spot using, where we have to be in the same network. And usually what we do is we just use our own hotspot, because then we're safe, we're in our own thing. Problem now is, with Azure Spatial Anchors, you need internet as well. And in here, as you may have noticed, you don't have mobile internet, which is why we have to use ETH network. So the way the whole system works is I'm in the ETH network. Spot itself, which I hope you will still see, has a nuke on top of it. A nuke, for those of you who don't know what it is just a PC that's the size of a small square. That's all it is. And it runs Ubuntu on it. The reason why he now carried down the screen, because it's Ubuntu and there's no screen attached to it. So we quickly need to make sure that we're in the same network again and calibrate the IP, and then we hopefully should be good to go. I can ask you quickly, are you connected to the internet, or is there a different problem?
It's all fine now. You can all turn off your Wi-Fi, but...
Yes, if you could turn off your Wi-Fi on the mobile phone, that would actually help us a lot. Thank you very much. I asked VIScon if there was another way. They said no, so here we are.
Okay. So ETH network, everything works fine.
All right. So, and also in order to make this more interesting for everyone, I can do a lot of things with the HoloLens now and tell you how great it is, but you don't see it. I can use this to live preview. I'm glad this is still working. So I can invite you to see what I see. There we go. There is I also have to check, 1, 2, 3 second delay. I will try not to move too much so you don't get dizzy. And I will actually, let me think about this for a second. I will start the app this way. By the way, if you want to try this out afterwards, I'll be outside and we can fool around with a robot. It's super fun. Yes, you're going to be on video, sir. So I'm going to start the app, which we've coded together. By the way, huge thank you to my robotic counterparts. He's also there to make sure everyone is safe. We also asked no one to sit in the first row. It's still a robot, but don't worry, you should be safe. He has the key combination ready in case Spot freaks out, which he did in a few development cycles. He can just hit it. Cool. So here I am. Let me take a step back so you can see what I see. I'm going to fall. We have just a little interface over here. So what's going to happen first? I need to connect to Spot. So I hit Enter IP. I hope. There we go. Let me increase the volume quickly so you hear what I hear. And I hope Italo Brothers, This Is Nightlife doesn't start playing. There we go. Cool. So what he just did, he started the Spot, the app that runs on Spot, which just means he's now ready. He's standing there, ready to go. He's waiting for commands. But first, for me to do that, I need to connect. So I will ask my assistant quickly what the IP address is, and I'm asking you not to DOS it now. 10.6.87.80. All right, and now I'm going to hit connect. And now I will ask him if you have reached the connection, received one.
That looks good.
Cool. So all of these things, we could, of course, add implementations like getting feedback, but we thought let's make this hacky and fun for everyone. So I will have to coordinate with him. He has the console in front of him. Cool. So the next thing, as promised, we have a little anchor item here, which I will take. And for easiness sake, I will just place right here in front of him. And by the way, as a test thing, let me see if I can grab this. Beautiful. I actually have two little joysticks here. Let me try to move them so you can see both the Spot and for those who are in the back row. And I can move Spot around with these joysticks. So the reason why I want to do that is quite simple, because what's happening now is, you see the anchor, that's only the location where I want the anchor to be. Sorry, I have to wait 3 seconds. So what I'm going to do now is I will hit the Create Anchor button. And once I've done this, my HoloLens will now start creating an anchor. So it's going to look at the visual features around it. It's going to turn green. And as soon as I have an anchor created now, I will send Spot the ID of this anchor. So he's going to start looking for it, and I will ask you if you found it already.
You found it, and it's exactly 2.2 meters in front of the robot.
Perfect. So what I would have to do is I could move Spot around to make sure he sees everything and he finds the anchor. But with those few steps that he did, he already had enough information, so he knows where it is now. Which means Spot and I are now in a shared mixed reality. So we can start doing dumb stuff. Let's do that. So here's my bowl. Oh, it fell down. There we go. And I'm just going to throw it somewhere there, and I hope it doesn't... Yeah, sometimes it happens that it falls through the floor. So the reason why that is, the floor is tracked by the HoloLens. I'm just going to put it manually here. The floor is tracked by the HoloLens. So I didn't walk here before with the HoloLens on, and it seems to struggle with the odometry. There we go. Anchor is still there. Let's try that again. There we go. All right, maybe don't put it that far, just put it over here. Thank you, okay, good. All right, next thing we're gonna do is we're just gonna hit fetch, and then he hopefully goes to the ball, picks it up, and then brings it back, and the ball fell again. We're gonna be here a while. No, I'm kidding, let's do this quicker. Yep, the floor. So it always is depends on how the floor is, I guess the pattern on the floor makes it difficult, and the HoloLens clearly struggles to find the floor. So I'll just put it a bit closer to me, and then we should be good. This is not part of the demo, by the way. Thank you. All right, let's hit fetch, and then we see what happens. So what actually happened is he ran to the ball now, but the ball fell through the floor. So what's happening now, he is eagerly awaiting to be close to the ball so he can pick it up and bring it to me. So what we're going to do is we're going to quickly help him. I'm just going to put the ball on him, and he should be picking it up. There we go. And I was going to collect himself and hopefully bring it back to me. There we go. Good bot. All right. There's one last thing which I also implemented, which is just a cute little come here button. Let me reset the ball quickly. There we go. So there's a lot of fun things we can do. Another thing, I forgot my menu over there. That's always the thing with mixed reality. It makes you walk around a lot. That's why all the robotics people are super buff. All right, let's do this. So I can just stand here and I can say come, and I just come here. Again, you're seeing a 3-second delay. It's really struggling with the narrow field here. But still, he's doing a very good job. All right, let's do one last time with the ball, and then let's end this. Please don't fall through the floor. Thank you. There we go. So he's fetching it, putting it on, and then he's coming back and bringing it back to me. All right. Cool. Glad that worked. So let me close this presentation and give you final remarks. So I hope I managed to convince you somewhat that it's good to have robots shared in the mixed reality world. The other thing which I want to put in your head is stay curious. I've been working in mixed reality since, I guess, 2017. In 2017, I did my master thesis with the HoloLens 1. Yet the whole robotics thing, it's still in mixed reality, but I was introduced a few months ago only. So I guess what I'm trying to say is stay curious, even if it's in your own field. I know people always say look left and right. That's also super important. But also in your own field that you think you're very good at and you think you know everything, keep looking around. There's always new things to discover. Cool. Thank you very much. And thank you to Jonas for helping me. And I'll also be open for questions now. I don't know what we are with time. So we got one question, so where do you apply? Actually, that's... I I know you said it slightly jokingly, but jokes aside, there are openings, I think, right now in the mixed reality and AI lab. The best place to start is look at, I think it's careers.microsoft.com. Type in Zurich. We have more and more openings, which is really nice. We're expanding the lab. It used to be only computer vision PhDs, but now we have robotics. We also start hiring software engineers. So we're really expanding. And if you like, doing stupid things with high tech, I shouldn't say that. Microsoft does. There is a 3-day hackathon every year from Microsoft that's internal, and we can just do whatever we want. And so this was my hackathon project, actually. So the doing stupid things actually is only half joking. The rest of the year we have to work, of course. Okay, other questions? I'll also be outside afterwards, and you can play around with Spot if you want to. There was a hand raise. What I do in my job at Microsoft, general.
Probably don't do this all day long.
No, I do not do this all day long. Unfortunately not. So my role is a bit special because I'm a program manager. I'm the only program manager in the mixed reality and AI lab. I think to summarize it, I make sure the other people can work. So, for example, we work together with other companies on these projects, and also to push the Azure Spatial Anchors. Dream right now is instead of having multiple anchors, you have one anchor and then you scan the features around it. Wouldn't it be nice if we can just move away from that and just have a map, just like everyone's brain is working right here in this room. You don't create anchors in the room. You just know where the room is, and if I put you somewhere, you know where it is. So to reach that goal, you need a really good basis of computer vision people. And also, it's good to partner with other companies to see where they're at. Boston Dynamic, for example, because there's Spot. It's to interact with different partners, and I make sure these communications happen. And it's basically a lot of enabling from my side, so the other people can also do coding and work on the research. So, but a lot from the lab, the majority of the project, of the people are working on Azure Spatial Anchors, which is the fundamental underlying work that enables all of this. Yes, so what is needed to make the mixed reality interface more fluid without lagging? Good question. Did you ever wear a HoloLens? Cool. So the thing is, this projection that I'm doing, let me show you the HoloLens. HoloLens actually has 5 cameras. I'm putting it in quotes because there's 2 on each side, and that's used for tracking. We don't have access to those. There's one, it's almost like a selfie cam here in the middle, and that's only used for this kind of projection. It's not very good. It has this delay, which you noticed, and also if I move my head too quick, then, well, everyone gets sick while watching this. So the experience you have on here is definitely not the same that you have on here. For me, it's perfectly stable. I'll happily invite you to try it out afterwards, outside. And you can wear it, and you can tell me if it's still unstable. Other questions? Yes? Okay, let me repeat the question. So you wore the HoloLens before you tried it, but you had problems with the depth perception. Yes, I've heard that before, that because the HoloLens, everything's in focus, even if things are further away. I know there's already research going on, and also with other mixed reality devices, that try to challenge this, which means you on purpose make an object blurry so it makes sense in your head. For the experiences I've seen so far, it always depends on what scenario it is. But so the experience that you saw me doing, for example, I don't mind if I don't have the depth thing. It still feels like it's away because as I move, I know it's standing over there. So I still get it in my head that it's over here. So I don't need the blurry thing. I'm actually happy that things don't get blurred as I walk far away, because then I always have all my information there when I need it. If you're thinking more towards gaming, 100% agree with you, then you need the blurring, or even maybe movies, just any kind of these scenarios. There it's more important to be fully immersed, wherein as the industry scenarios that I showed you before, maybe there it's more important that you have the information and it should be in focus, and you can kind of get over that lack of spatial perception. But again, if you move around wearing the HoloLens, you will still feel like there's depth to it. But yeah, good question. Any other questions? With HoloLens, Spot, robotics, Microsoft? Yes. Okay, so the question was, it's called Mixed Reality and AI Lab. That was all mixed reality that I talked about. Where's the AI? That's a good question. Because I asked myself that as well. I guess the AI, it depends on your definition of AI. Maybe you could even argue that spatial anchors is a part of artificial intelligence, and we are giving Spot with spatial anchors, for example, we're giving it artificial intelligence because it knows where it is. So I think this is where the AI comes from. Maybe, we shouldn't put that on record, but maybe you could say it AI for mixed reality. But so we're not doing, at least our lab, we're not doing general AI. We're focused on mixed reality and making the HoloLens a better product. Yes. Okay, so the question is, where do we see the HoloLens going? Right now, we see it in industry, and if we see it in consumer space as well. Was that your question? Like, where's the trajectory going? I guess the real answer is no one knows. I know initial with HoloLens 1, the dream of Microsoft was a bit to have it as a consumer device, but a HoloLens costs around $3,000, I think, and as a consumer, you want games or productivity tools that just work out of the box. And for games, anyone who's into gaming, with $3,000, you can get a really nice gaming PC, and you can play a lot more games on it than the 4 or 5 we have on the HoloLens. So with HoloLens 2, it was a strong stance in the direction of industry, because we noticed that's where it's being used the most. That's where we can help the most. That's where we can have the greatest impact. Whereas consumer devices, it's a super fun toy for a consumer, I think. So anyone who's tried it, I hope they agree with me. If you haven't tried it, feel free to try it afterwards. It's a fun device, but it's not something I would right now use every day, at least in my job. But in other jobs, so the ones we've seen before and a bunch of other industries, I guess this is where the trajectory is at the moment. The dream is still, and we see this in other companies as well, which I'm not going to name now, there is a strong walk towards augmented reality and mixed reality, as other companies are also setting up the whole environment, the whole ecosystem. So it's still a bit in the air where it will actually land, but a strong bet is on industry right now, and we assume consumer will also follow at some point. It's not going to be next week, not next month, but year, 5 years, 10 years, somewhere around there maybe. Yes, question. How do we improve the AI model that we currently have? Good question. It's getting technical now, like it. I don't know all the details, again, because unlike a lot of my peers, I don't have a PhD in computer vision. What I know we're doing is, of course, the idea is you collect data and you make sure let me break it down, super simple. I want to walk around with my HoloLens here, just what I did before. And then I want to put Spot or any other device anywhere here, and it should immediately know where it is. Again, for us humans, it's easy. If I would make your eyes closed and just put you anywhere here, and as soon as you open them, you would know. The exact underlying algorithm, I don't know the details, but there's always, you can always find a case that are difficult. One simple case, which is if the background is very monotonous. This was, I guess, Borderlands. Okay, we have edges here. Worst case is a perfectly white room with nothing in it. There's no features whatsoever. I've actually asked the lady over here to not move her jacket in the beginning, because it's a super good feature for the Spot. But if I would create an anchor and she would remove the jacket afterwards, I would assume there's enough features around, but still it would make its life more difficult. So this is where there's still room for improvement. There's wormholing as well, which happens a lot. Wormholing is if something looks similar. If I would capture this room and the room next to it, which looks super similar, and then I put Spot here, this exact image looks the exact same as in the other room. So he might think he's in the other room. So there's still a lot of room for improvement where things can still go wrong. Yes, sorry, what is the biggest problem that we go to consumer device? Cool question. One, I'm sure, is pricing. The other thing is size. So I think I'm not reaching too far out if I say this is the only mixed reality device that is not tethered to anything. So one of the other famous mixed reality products is, of course, the Magic Leap. And one Key difference, whether it's good or bad, I'll leave up to you, is as I wear the Magic Leap, I have a cable that is attached to somewhere on my pants, which maybe makes sense because they can have more computing power. Here, all the computing power is on your head, which means you always have to trade off how much power you want to give this. Of course, you can have a whole gaming PC on your head if you want that, and then you have super performance. No one's going to wear that in a consumer device. So you want to make it as small as possible, but then the challenge comes, well, how much hardware can we still fit in there to make the performance appropriate? So that's definitely one of the challenges. The other one is just simply acceptance. Most of you may have heard of Google Glasses. That project came and then went again. So for those of you who don't know Google Glasses, it wasn't really a HoloLens. It was a screen but a heads-up display. So you would have extra information, but it wouldn't move like with the HoloLens. It would just stay in your vision. So if you move your head, it just stays there. Again, depending on the scenario, that could make sense. I think with Google Glasses, the difficulties was there was a camera attached, which was always on, or you didn't know whether it was on or not. And so there it goes back to the acceptance thing. Even if you would wear it, maybe the people around you don't like you wearing it. So there's the whole social concept behind it too, and the size. Those are the two things that are on top of my head. Why it's still challenging to get into the consumer market. And it's getting tired too. Yes. Nice question. So the question was, does it share any mapping information that it creates with the Spot? The answer right now is no, other than the spatial anchor that we created and the features around it. So the map that it creates, you're absolutely on the right track. Ideally, as I walk around, all this map is streamed into Spot. And as I update the map, as I walk further, that map is also on Spot now. So the lab is currently working towards that direction, just to have a map that everyone can share and everyone can locate, not just Spot you with another HoloLens. You're in here, you see the same holograms immediately. And as we walk around, we map more of the area, and all this map is shared. So answer is, not right now, not yet. Thank you very much.